This is the last video from our functions notes. This is a function to calculate the payment on a loan. And we are going to ask the user for the input. The input is going to be the principal, the amount borrowed. And I'm going to copy and paste in some code here. So we're going to ask them how much money they borrowed. We're going to ask them what the annual interest rate is. And we're going to ask them for how many years. And then when we get that, we will, I left out 2 lines here. So we'll read in principal, annual rate, and years, and then we will tell them what their monthly payment is. We're going to write a function called payment. It's going to accept the 3 things you need to compute the payment: the principal, the annual rate, and the number of years that the money is going to be repaid over. So it's going to return a double. Name of it is payment. We're going to accept a principal, which is going to be a double. We're going to accept an annual rate. I'm just going to call rate in here. Whoops, got to put double first. And we're going to accept an integer, which is the number of years. We're not going to allow a fractional number of years. Okay. So we need to know what the formula is for calculating the payment on a loan. And the payment on a loan is you take the principal times the rate per period, and that's going to be our numerator. So before we can do our formula, we need 2 more values here. We need a rate per period, and we need an integer, which is the periods, payment periods. Okay, so if you're borrowing money for 1 year, let's say at 12%, because that works out real nice, then you're paying 1% per period. If you're doing 12 monthly payments, just divide the annual rate by the number of periods in a year, and that will give you your rate per period, and the number of periods is going to be the years times 12. So our numerator is going to be the principal times the rate per period. Then I'm going to divide by, and the numerator gets, or the denominator gets kind of long here. It's going to be 1 minus the quantity 1 plus the rate per period. And that's all raised to the power of the number of periods. And there is no exponent operator in C#. So what we're going to have to do is we're going to have to call the math class here, and there is, I believe, a power function. Yep. And it needs to know the base, or the number, and the power that it's being raised to. And the power it's being raised to is minus the number of periods. Okay. Now I guess I don't really need, as long as I've got the comma there now, it will calculate that sum first, and then I need 1 to close off the denominator, and we will put a semicolon on the end of that. And I am getting some error messages here because I forgot to calculate the rate per period and the number of periods first. So the rate per period is going to be equal to the rate divided by 12. We're assuming monthly payments here all the time. And the periods is going to be equal to the number of years times 12. Okay? Okay, now before we run this, I'm going to comment out this part so I don't have to answer the questions from the last function. And then let's go ahead and run it. And I have 1 solution memorized. The answer to this is, I think it's $514.31. So 50,000. Annual rate is 0.12, and number of years is 30, and $514.31. Okay, so it is calculating correctly. And one thing I should probably do here is, you notice when I wanted to enter the interest rate, I didn't put a decimal point in front of it. And, usually you don't because those numbers are quoted as percent. So 12% would just be 12, not 0.12. But you do have to divide that by 100 here. So I'm going to run it again. And this time when I run it, I will not be required. I'll just put in 12 instead of 0.12 and 30 years and $514.31. Okay. One brief thing about our right line statement here. This is the formatting string, and inside the curly brackets, argument 0 is going to be whatever the first argument here is, and there's only one following the comma in the formatting string. And the colon, what follows the colon is a C and a 2. The C stands for currency, and the 2 means with 2 decimal places. So you notice there's a $sign in front of the 514, which I didn't explicitly put any place. This is where the $sign came from, the fact that we put a C there instead of an F. Okay, and that's the last function example for this set of notes.